Right now, somewhere, a prairie dog is watching you. It is not just watching, it is describing you, your height, your shirt color, how fast you're walking, and it's saying all of it in under a tenth of a second in a language built specifically to talk about creatures like you. For decades, the question of whether animals understand human language got asked the wrong way around. We kept testing whether they understood us. Almost nobody asked whether they were quietly building a vocabulary about us instead. The prairie dog research changes that. Biologist Kon Slobodchikov spent over 30 years recording alarm calls in prairie dog colonies, and what he found wasn't a simple warning system. It was closer to reporting. Researchers walked through colonies wearing different colored shirts, blue, green, yellow, and the calls shifted measurably depending on what they saw. Not random panic. Specific, structured description, size, shape, color, speed. Sounds that had never been used before, recombined to describe something the colony had never encountered. So when you ask whether animals understand language, you might be asking the smaller question. The bigger one is whether some of them speak about us in a language of their own. Dogs are where most people start this conversation, and most people stop too early. In 2016, researchers in Budapest trained 13 dogs to lie motionless inside an fMRI scanner. Hungarian neuroscientist Attila Andix wanted to know something nobody had ever measured, not whether dogs respond to words, whether their brains process meaning the way ours do. The scans showed dogs splitting language the same way humans split it. Left hemisphere for word meaning, right hemisphere for tone. Two separate channels, processed separately, then merged. But here's the detail that rarely makes it into the highlight reel. The reward center, the part of the brain tied to pleasure, only activated when the word and the tone agreed. Say, "well done," in a flat, bored voice, and the dog's brain registered a mismatch. The meaning and the music had to align. Is that language comprehension? Or is it something more like emotional pattern matching dressed up to look that way? Even the researchers aren't fully settled. A follow-up study found an error in the original hemisphere assignment, left and right reversed, and had to issue a correction. The field is still arguing with itself. Then there's Rico, the border collie who knew 200 words and could infer a new one by process of elimination, a skill called fast mapping. It made headlines as proof dogs think like toddlers. What gets left out is how contested that interpretation still is among scientists, and how much harder the next step turned out to be. One dog, a mongrel named Sophia, took years of careful training just to combine two words into something resembling a sentence. Ball, fetch, stick, point. Single data points, not species-wide certainty. Now go underwater, because this is where the story stops being about pets and starts being about grammar itself. In the 1980s, at a marine lab in Hawaii, psychologist Louis Herman taught two bottlenose dolphins artificial languages built from arbitrary rules. Phoenix learned an acoustic version. Akeakamai learned a gestural one built from her trainer's arm movements. Both dolphins could tell, "take the surfboard to the person," apart from "take the person to the surfboard." That's not vocabulary. That's syntax. Word order changing meaning. The exact mechanism your own sentences depend on. Akeakamai could even report when something wasn't there at all, signaling absence rather than just obeying a command. And her language ran on different rules than Phoenix's, and inverted grammar, yet she never confused the two. The strangest moment came when she was shown commands on a television screen for the first time in her life. No training, no warm-up. She responded correctly to gestures on a flat, glowing rectangle the very first time she saw one. Something in her had generalized the rule far past the conditions it was built in. Is that language, or is it something else wearing language's clothes so convincingly that the distinction stops mattering? There's a smaller, stranger study worth sitting with before you decide. Goats, an animal nobody credits with social sophistication, were shown photographs of human strangers, some smiling, some angry. No rewards attached to either image. The goats consistently chose the smiling faces first and stayed near them longer. Nothing taught them that. Somewhere in a goat's nervous system, a human face already carries weight. So return to where you started, standing in a field, being measured by something that cannot speak your language but has clearly been listening anyway. Somewhere, a prairie dog is still watching you. It already knows what it thinks of you. It decided that a tenth of a second ago